Okay, I lied. We're gonna do a third video. I want to come in and do a couple of. I have more things to say about this because synthetic division is such a beautiful mathematical tool that you guys have. All right, so I did show the work for number 2 there. So hopefully you've tried that, and you'll see that with the synthetic division. I just went ahead and went straight to synthetic division because it's much easier. I got a remainder of -34, so it tells me the remainder's not 0, that f of -2 is -34. Therefore, x plus 2 is not a factor, and -2 is not an x-intercept or 0 of f of x. So I did want to kind of talk about that. I'm actually going to come back to one of the earlier ones that I asked you to do. I'd asked you to, on page 3, to do this verify here. But I wanted to show you something. There's something really interesting about synthetic division and this idea that as we're factoring, we can just kind of keep factoring. So notice that I did them separately, and I did it up here for the first one as well. I just went back to the original and divided it to show you that it was 0. But I do want to show you something here to kind of show you how to get factors. I'm going to start with this problem right here. So I'm going to kind of zoom out a little bit and come over here to the side. So if I started this process and say I knew that there was 1, 0 of this polynomial and I knew it was -2. So 1, 2, -1, -2. You can run your synthetic division because it's really quick. 0, 0, -1, 2, 0. And you would get to there. You can actually keep going and add on the other zeros and just keep doing synthetic division. So like the next one is a 1. I'm going to do that and say I'm just going to draw a line and then I'm just going to keep going. Drop 1, 1, 1, 1, 0. The key that you're looking for is each of these are going to be the remainders, each of the little ending part. And then I can keep going one more time. And if I were to divide by the -1, drop your 1, 1, -1, 0, and you get to this idea that, see how we're dividing it out and all 3 of those were zeros? We could keep doing this. We could drop out of synthetic division at each point in time. If I drop out right here, let me do this in red. So if I drop out right here, let's just come over to this, then I know that my polynomial would be x plus 2 times x squared minus 1. I remember our polynomial we started with was x, hold on, this was x, what would we start with? Sorry, my bad. Yeah, it was x cubed. So I started with x cubed. So I had x cubed plus 2x squared minus x minus 2. After that step, I know that it's equal to the x plus 2 times x squared minus 1. If I keep going, when I get to this step, and at that point it's quadratic, I could just factor it. I know that it would be x plus 2, and then notice that we would have x minus 1 from this. And then our part here, down here at the bottom, that I underlined, that's your x plus 1. And so it's the idea that you can keep finding all the factors and keep moving down slowly through it to see that you have there. Now, what I thought was interesting, especially that I wanted to talk about, like here at number 2, if I'm looking at that, notice that this x minus 1 factor right here, it's a factor 3 times. So what that means, oh shoot, sorry, that it's a factor 3 times. So what that means, when you have something that's a factor 3 times, that means it has to divide into it 3 different times. So notice that if I go to repeat this, so at this point right here, I'm just going to add another 1 and divide it. So drop 0.4, 0.4, that's 0.6, 0.6, that's -1, -1, 0. See how it worked a second time? So that's number 2. And then if I do it one more time, 0.4 and then 0.4, that adds up to 1, 1 and 0. See that it divided into it evenly a third time. So every time that we're kind of doing this problem, we can be basically getting all the factors that are there. All right, so let's come back and let's look at this last part. Since I'm doing the video anyway, we might as well do some of it together. All right, so let's look at our problem. We have a function x cubed minus 13x plus 12. The first thing they want you to do is divide by x minus 3 and then factor. So I'm just going to do synthetic. 3, 1, don't forget your placeholder, negative 13 and 12. And you'll see how fast this goes. You know, it's actually interesting because my screen's lagging behind me a little bit, but it's a little bit thundering out here now. So drop 3, 3, 9. The trick is to not make any mistakes as you go. Right, so I get to that point, and what I know at that is that x cubed minus 13x plus 12 is going to equal x minus 3 times x squared plus 3x minus 4. And then we can continue factoring, right? We can just go ahead, because it's a quadratic. Once you get to a quadratic, x, what do you have, plus 4, x minus 1, and then we would done, and we have all three zeros, okay? If we look at divide by x minus 1, now this is kind of the trick that you're looking at it. If I take the original, okay, and divide by x minus 1, then I'm going to have 1 going into 1, 0, negative 13, 12. So 1, 1, negative 12, negative 12, 0. Now we know, and let me just slide this, undo, I'm getting excited here. Just going to move that over a little bit. All right, so here we know that x cubed minus 13x plus 12 is going to be x minus 1 times x squared plus x minus 12. And now notice if I continue factoring that, I get x plus 4 and x minus 3. See how it still works? And that you get the exact same factored form of the polynomial. You just kind of went there in a different way. And so that kind of ties into this idea of repeated factoring that we have. And then just to kind of really beat the dead horse, let's do it one more time. We have 1, 0, negative 13, 12. It's a good thing synthetic division is pretty fast when we're doing it, because it really is this really quick way of dividing. And as long as you just remember, drop, multiply, add, multiply, add, multiply, add, you'll be fine. So here our x cubed minus 13x plus 12 was x plus 4, x squared minus 4x plus 3, and you guessed it, that is going to factor to x minus 3 and x minus 1, and we still get the same three factors, so it works out that way. And again, what are the zeros? The zeros are 3 and negative 4 and 1 based on that. So now the next question says, so we're just kind of continuing on, just doing a little extra practice here. If x minus 1 is a factor, what are the other two factors, and write it in completely factored form? So again, it's this idea that I'm just going to go ahead and do synthetic start. 2, negative 3, negative 2, 3. Drop, multiply, add, multiply, add, multiply, add. So that's a factor. Very clearly, we get to the end and we get a nice remainder of 0. So again, once you get it to a quadratic, we're golden at that point. So g of x, which was 2x cubed minus 3x squared minus 2x plus 3, is exactly the same as x minus 1, 2x squared minus x minus 3. And at that point, we can go ahead and factor, just using good old guess and check. 3, 1, and I need a minus plus. And then so at that point, it's in completely factored form. So my final part that we're looking for, completely factored form, would be that last one right there. At that point, could you answer the question about what the zeros are? The zeros of g of x, my x-intercepts, would be x equal to 1, 3 halves, and negative 1 if I needed that for my x-intercepts in graphing. All right, let's look at 6. X plus 2, I'm going to leave that one for real for you to do on your own here for number 6, because that's very much the same. Let's look at number 7 together, because I think that's a little more interesting. For what value of k is x minus 2 a factor? Again, remember, to be a factor, it has to have a remainder of 0. I'm going to use synthetic because it's way faster. So I need a 6, negative 19, k, and 6. So drop, multiply, negative 7, negative 14, k minus 14. Let it pause and let it catch up. Multiply by 2, 2k minus 28, 2k minus 22. So there's my remainder, and I need that to be equal to 0 for it to be a factor, and then just solve your equation. 2k is 22, k equals 11. All right, we're going to leave number 8 for you to do on your own. And then let's do that number 9, and that's that thing that I was talking about earlier, which is this repeated factor. So x plus 1, so let's do negative 1, negative 3, negative 7, negative 3, 3, and 2. So we run our synthetic division the first time. So I drop, I multiply. So I'm just doing the arithmetic. I'm doing it fairly quickly. You guys can slow it down and pause if you need to. But it's one of those things where as you do it, you get better at it and you can do it fairly quickly as you're going down. So obviously it works, right? The first time. I'm just going to try it again. It's what I call rinse and repeat. So try it one more time. So draw your line, drop, multiply, add, multiply, add, multiply, and I got 0 again. So it worked a second time. So now I know that it is a factor twice. Let's try it one more time, see how it works. Drop, multiply would give me 3, 2, negative 2, 0. Oh, look, it worked a third time. So that's negative 1. Should we try it one more time? Let's see what happens. I don't think it's going to work on this last time. Negative 3, 3, and then clearly that's going to give me 5, and that would be no. This one did not work, so let's cross that one back off. So it's 3 times, 3 times. So I know that this polynomial f of x, which is negative 3x to the 4th minus 7x cubed minus 3x squared plus 3x plus 2, it's going to have that x plus 1 factor 1, 2, and 3 times. So it's going to have a cubic up there in its power for that. And remember, there's only going to be 4 factors because the degree of this is 4. And then what's left here is this, let's do that. Right there was where we ended when we stopped the process. Let me come up here. All right, that's the last time that it worked. That factor that's left, remember we started at an x to the 4th. This one was x cubed. This was x squared. This is now x. So that's negative 3x plus 2. So the zeros of f of x are negative 1 and 2/3. And the negative 1 has a multiplicity of 3. It is a factor 3 different times on this graph that you have, which is odd. So we know that if we did a sign chart, it would change signs, but it happens to be a repeated 0 of 3 times. All right, so now I am truly done with this set of class notes, and you guys just have a couple of problems left to do on your own and to do the worksheet for homework.